Alright, so move this recording icon down here and get started with this lesson. I'll go from the beginning here. I'm just going to walk through the PowerPoint. I'll switch over to ActiveInspire when I need to. This opening lesson in this unit is called the Logarithmic Function. Some of you might have seen logs. Well, you might have seen it on your calculator. There's a log button on your calculator, but also you might have seen this in chemistry or biology. Logs come up once in a while. But I'm going to approach it like you've never seen it before, and we'll go right from an introduction type of thing. To get started, we need to do a little review on some stuff from grade 11. And it's the appearance of the graph of an exponential function. So I want to look at three different exponentials that were kind of the base functions that we used in grade 11. The first one is y equals 2 to the x. You can see it here on the left-hand side here. And making the graph of 2 to the x, like always, I say you can easily get these graphs from a table of values. I mean, that's not the fastest way to handle it, and you've got to be better at it than that. But if you needed to, you could go, okay, what's 2 to the power of 0? And anything to the power of 0 is 1, and that's how we get this point right there. And then you could put in 1 for x, and you go 2 to the power of 1 is 2. And you put in 2 for x, and you get 2 to the power of 2 is 4. And 3 for x, you get 2 to the power of 3 is 8. A little more difficult going to the negative numbers. 2 to the power of negative 1. Well, negative exponents become positive exponents. 1 over 2 now. And you get 1/2. You can punch in your calculator as well. 2 to the power of negative 1 will give you 0.5. And 2 to the power of negative 2 would be 1/4. And then you get this graph. And similarly for 3 to the x, you see 3 to the power of 0 is 1. Well, and right away, you should remember, okay, anytime you put something to the power of 0, you get 1. So there's 3 to the power of 0 is 1. And then 3 to the power of 1 is 2, or is 3, and 3 to the power of 2 is 9, and away you go. And similarly, this is kind of when we first saw asymptotes, was last year, as it goes off to an asymptote back here. 1/2 to the x is a flip in the y-axis. We'll talk about more about why that is, but it's becoming 1/2 every time. So if you put in 1/2 to the 0, you will still get 1. If you put it 1/2 to the negative 1, now you'll get 2. Try it. Put 1/2 in brackets and put it to the power of negative 1. You'll see you'll get 2. And it's because the negative is telling you to flip it, so 1 over 2 becomes 2 over 1. And that's the 1/2 to the x function, thinking it through that way. It's getting 1/2 every time. Now, I've got to switch this pointer, go to the next screen. We want to talk about the inverse of an exponential function, and there's one big idea I want to refer to an inverse of an exponential function, is that the roles of x and y now get reversed, or inversed. X's become y's and y's become x's. Now, algebraically, we've seen that a few times. We saw it earlier in this course about algebraically switching y and x, but I just want to talk about it graphically. If you want to reverse the role of y and x, again, we're going to put y equals 2 to the x up on the screen here. And again, these points, these key points are just got from thinking it out. 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of negative 1 is 1/2, and then you can put the rest of that graph in there. Now, to reverse the roles of x and y, two ways to look at it. One is to look at it as a reflecting the graph y equals 2 to the x in the line y equals x, which is switching the x and y coordinates. You see right down here, switching the x and y coordinates. And I'm experimenting here a little bit with this stuff, so I'm going to turn the highlighter on. Switching the x and y coordinates. So, I'm going to draw a line on here. The line y equals x. You can see every x value is equal to the y value. There's 1, 1, 2, 2. 3, 3, 4, 4, and similarly the negatives. And if you just imagine taking this graph and flipping it over there, we're going to get something that looks kind of like that. Can you see the way I'm moving my mouse? Okay, just to get the idea. And I'm actually going to flip the points. But I want to talk about, before I flip them, where the points come from. See, 0, 1 right there becomes 1, 0 right there. You're just flipping the x and y points. 1, 2 becomes 2, 1. 2, 4 becomes 4, 2. And here they come, all those points, either thought of as flipping over the line y equals x, see right there, it's flipped over top, or just reversing the roles of x and y. Either way that you want to look at that is fine. So there it is, the graph of the inverse of y equals 2 to the x. And for now, it's just on this screen, it's just called the inverse of y equals 2 to the x. Some questions come up. Is the inverse a function? This course is called functions. Geez, I hope it's a function. I mean, it didn't have to be, but it is. If you look at it, it passes the vertical line test. No vertical line is going to pass through this graph more than once. Notice it doesn't exist over here, though. So that's going to come up in our analysis over here, as it doesn't exist for negative x values. That is, you can't go 2 to the power of something and get a negative. Okay. So is the inverse a function? Yes. Now notice that the graph of y equals 2 to the x has a horizontal asymptote right here along the x-axis, and the inverse has a vertical asymptote along the y-axis. So it's there. All right.